Okay, so in this video, I'm going to explain inverse functions and kind of the basics of it and skip over all of the unimportant stuff. So first of all, what is an inverse function? Inverse function is essentially the opposite or kind of the reverse of a function. I feel like it's not too important to actually understand that, but it's more important to understand these other examples that I'm going to go through. But just to kind of satisfy us, I wrote down like the definition over here. It's not, I don't think that would be the proper definition. I think more proper definition would be an inverse function is a function that undoes what the original function is. So that's why I actually pulled up these two examples here. F of x is equal to x squared, and also f of x is equal to square root of x. Because essentially, the opposite of a square is a square root. If you have something that, so if you basically apply a square to a square root, the opposite of that, what you have to do to undo that mathematically is just square root that, right? Then you just get x. So these two are the inverse of each other, essentially. Another way that you can kind of look at inverses, or for me to explain inverses to you, is if I give you this set of coordinates, then the inverse of that would be just the x and the y variables switched around. And also, same thing if I have a table of values, right? If I just have like, I don't know, random table of values, so let me just make one real quick. Uh, just put in some random numbers here. So make these like, I don't know, I don't have a particular order to this, but yeah. So then basically, the inverse of this would just be the coordinates flipped around. That's it. That's all that inverse really is. Now, you can actually show this. So I kind of showed you like in terms of coordinates and like in terms of the equation. And we'll get into how to convert between inverse functions like algebraically, how to go from the original to the inverse, find the inverse basically. But first I want to show you like something graphically. So essentially what I want to show you is just that inverse functions are essentially just reflections across this line, this diagonal line of y equals x. So basically, like, just imagine a diagonal line going through this Cartesian plane, right? And the actual function that it is, like, the to describe that line, we have the equation y equals x. So that is like in a relation. That's a relationship in itself, right? That basically just means that okay, this is 1 point, this is 1 comma 1, and this is 4 comma 4. I know this line isn't super great, but it's supposed to be like that, right? So -4. You get the idea, right? So okay, yeah. And as I was explaining earlier, an inverse, the original and the inverse of a function are just a reflection of each other across this y equals x line. So imagine if I had a function like over, like, let's say over here, or better yet, I think I could give you a better example than that. I think I'll just keep it linear, perhaps. So like imagine you had a function like your f of x, something like this, like maybe continue the line, but yeah. So this is like your f of x, right? And your inverse, the notation that you want to represent your inverse in is basically just this, like sort of like a negative exponent. Not don't take that too literally actually, but it kind of the way that the notation is that it looks like a negative exponent as I detailed over here. So yeah, and so let me actually write the inverse, draw the inverse. Yeah. So it's kind of weird. You have to imagine. So like if this y equals x line is like the mirror, you have to imagine this f of x function flipping over to the other side. So like almost like going that way and then just flipping over that way. It's really weird. I can't really represent it with my hands, but yeah. So it's not. It might not seem intuitive at first, honestly, but it'll take some time. So yeah, then this will basically look something like kind of like that, flipped in the other way. And although I didn't graph this accurately, essentially, all as I was representing here with the table of values, the coordinates for f of x are the same as the points for the inverse of f of x, but the coordinates are just flipped around. So basically, this isn't accurate at all, but if I were just to give you an example, like let's just say that this coordinate is like 3 comma like 7. I know it's not gonna be accurate at all, but we would expect to find a point over here that's like 7, basically the opposite, 7 comma 3. Well, it's actually not too far off, honestly. If you look over here, yeah, 7 comma 3. Yeah, it's not too far off. Yeah, not too bad. Okay. So yeah, you can see you get the idea of inverse graphically and in terms of coordinates now. So the coordinates are just flipped around. The x and the y variables just interchanged. Um, Graphically, it's just a reflection on this y equals x line. And then you can represent this with, you can even do the same thing with, sorry, there's so much stuff going on here. But you could represent the same thing with like parabolas, like with any function, right? So like, I don't know, you have one over here, and then you have like one that kind of goes like sideways or something like that. Yeah, I think that's good. So yeah, that's how it's represented graphically. But then now something very important is how do you find the inverse like algebraically, which is a question that's commonly asked. And of course, the questions can get like pretty complicated, but I just chose a simple one to just go over the idea and to just summarize it. You basically just need to, I'm just gonna write down, switch x and y variables. That's it. That's it. That's really all you need to do. So that could be like your step one, and then your step two would just be to solve for y. And then a bonus step that I'll just put down is like write in function notation. Yeah. Yeah. The reason I say that is just like because you might get a question that first starts off with like f of x, so like it might be like this, and then ideally you want to change this like the f of x part into y, and then you know you go through the whole process, solve for y when you do the interchange like switching around, but at the end just remember to switch it back to or switch it back to like this function notation where you have your final answer written like this, right? Something like that. So yeah, let's go about this question now. So follow my steps over here. So switch the x and the y variables. So let's do that. Okay. So this is x. This is y. So same thing. Like this is still being multiplied by 3. It's still being squared. Like literally all that's changed is the letter. So yeah. Now we just go about it. Solve for y. Yeah. I'll try to write out all my steps so it seems like very clear as to like the math that I'm doing. I think the way that everyone does math is a little bit different. So it's crucial to show all the steps when you're catering to new people or different people. So, and let me just verify that I did my steps correctly. So I switched the x and the y variables. I brought the 2 to the other side, so that became a negative. And then I divided this whole side by 3. So from here to here, I just like uh, put the y on the left side, this side on the right side, just to clarify. And yeah, divide this whole side by 3 and then square root it. Yep, and that should be not our final answer because we have to switch this into function notation. So inverse function. So yeah, that's how you go about it. These questions can get more complicated, but really it should be fine if you just understand these basic principles and your algebra skills are up to date. You should be good. So yeah, stay up to date on your algebraic skills. Keep yourself sharp. So yeah. All right, and that's pretty much all I wanted to explain about inverse functions. They honestly aren't too bad. But yeah, I hope this lesson was informative.